is going to be surface areas of, volumes of pyramids and cones. And then we're going to talk, today we're also going to talk about spheres. I think it works out really well for doing this. So we're going to talk about the volume of a prism. Not prism, I'm sorry, pyramid. Volume of a cone. We'll do volume of a sphere. And we'll also do surface area of a sphere today. And that's basically all of our formulas that we'll look at. Today I'm going to do one combo area. Combo area of both, we'll do a combo area of the surface area and a volume of a, well, you'll see here in a second. And then from there, can you take off your earphones and put off your phone? That'd be great. Thanks. From that, then we'll talk a little bit about the spheres. Tomorrow, what we'll do is we're gonna put all of it together. We're gonna do all combo areas and volumes and stuff like that of everything combined tomorrow. And then on Monday, we do the ratios of surface areas and volumes. And then we will do the review on Tuesday, test it on Wednesday. That works out well. What I want to be able to do is I will get you guys the hard copy of the review stuff on Monday, because then what we'll go over on Tuesday is basically we'll go over the homework from Monday night, and then we'll do the review stuff off of that on Tuesday. Wednesday you'll have extra problems then for the test, guys. And then as we go on, I'll assign certain chapters for every day forward as we go from there. We're right on pace. We're in no rush. We got plenty of time to finish this stuff out, so it should be okay. Pyramids and cones. These are going to wind up being very, very fast formulas. When we're talking about the volume of a pyramid, volume of a pyramid is going to be 1/3 the area of the base times how tall it is. When I'm talking about this height, it is the vertical height. It's going to be the vertical height of the pyramid. Yes, sir?
When I looked on, I had some questions on Google, so I thought I had lost my sheet, and it said 90 times this.
And it depends on what the base is. If it's a rectangular base pyramid, yes, that's fine. But remember, big B here, it stands for whatever the area of the base is. So you can have a hexagon. Hexagon isn't a length times width, it's perimeter apple, all that kind of stuff. So yes, ma'am.
The way that you just said it.
Yeah, and that's in science stuff. Then you're all just using rectangle base ones, whereas here we're going to use all of them. All right. So you just remember it's big B, whatever the area of the base is, whatever that big B is, and again, it's all the formula stuff on your sheet. Okay. Volumes, remember they are always cubed because you're multiplying 3 dimensions together. So you have inches times inches times inches, you have cubic inches, and so on. Okay. What's the difference between a pyramid and a cone? Do you remember? Yes, you do.
A cone has a bottom.
It's a circle of a circle bottom, so it's a circle base. That means big B is always a circle. What's the formula for every single circle? Pi squared. So volume of a cone, 1/3 pi r squared times how tall it is. Okay. When we put these things together in terms of calculator work, yes, sir. Yeah, go ahead. When we put these things together in terms of showing work and whatnot, it's no more than just taking a value and just writing it out. You have the button on the calculator that creates a fraction bar. Use the fraction bar for the 1/3, and then just put everything together like we have in the past. So, quick example of a cone. Guys, quick example working with a cone. I figured to go right to one that you have to do extra steps with. So, if I'm going to work with the cone to find the volume of it, how much stuff I can fit inside it, I have the radius given to me. I don't know what the height is, but I know what the angle is created at the peak. So exactly. Just similarly to what we've been doing in the past, where a lot of times you have to do that one little extra step to figure out a part for the formula, it's going to be the same thing. Bless you. It's going to be the same basic principle. So if I know that I have my angle here, my theta, 13 is my opposite, the height of this is my adjacent. What's my trig function? The tangent of 32 is 13 over h. And what do we do whenever our variable is in the bottom? Exchange-o, change-o. Exchange-o, strange-o, yes, that person too. Okay? And then you press some buttons in your calculator. So this gives us, let's see, 13 divided by tangent 32, 20.80. That's my vertical height then, 20.8. Oops. So now I know that the volume is 1/3. It's a cone, so it's a pi r squared times how tall it is. Our radius is how much according to the diagram? 13. So here's what we do. This is how I would type this into my calculus. Fraction bar, 1/3 times 13 squared times 20.8 times pi. And you can throw parentheses around these if you'd like.
Wait, can you?
What's that? 20.8? Yes.
Wait. Because I had to at first I was
Think?
so confused.
I'm messing with you. Remember, your calculator has a fraction bar. Use it. It takes away messing stuff up. 1/3 times 13 squared times 20.8 times pi. Bless you. And that gives me my volume. What do you do with your units? Cube them. Thank you. So 3681.11. Something cubed. I wrote the units for you. Yes, sir. Because if you went through and took a cylinder of the same dimension, of the same circular base, same vertical height, you could take and fill it up 3 times with that same size cone. 3 cones would fit into one cylinder if the cylinder itself had a radius of that 13 and had the height of 20.8. If I took sand, and I totally forgot to bring this in. If I took the cylinder, the cone itself, and they had the same height at 20.8, radius at 13. If I filled up with sand, I would have to use 3 of them to fill up the same amount of space inside of a cylinder. Yeah. What's up? Sorry, I was middle of discussing. How are you?
Good, how are you?
I'm fine, thanks. So that's why that works. And it's the same thing with pyramids. A pyramid and a prism, if you had the same size base with the prism as you did the pyramid with the same vertical height to it, it works out the same. Okay? Yes, ma'am. We have to make a phone call. If you give me a second. Okay. Now, yesterday I didn't give you anything like this. But I felt like working backwards today would be a good idea. From time to time, what I want you to think about is when we're working with formulas as far as volumes and surface areas and everything are concerned, you could always solve for one of the missing pieces. Well, in this case, we're going to try and find, we have the volume of a triangular pyramid, and we're going to try and figure out what the vertical height is. Yeah, it's called the volume of a pyramid.
No.
I know, which means this is where you were this is what you were talking about earlier, length times width times height and all that volume stuff. But remember, when I'm talking about the pyramid here, the volume of a pyramid is the big B, 1/3 big B, how tall it is. In this picture, what's the big B? What's the shape? It's a triangle. So just like we have been doing all along, we say big B is a triangle. How do you find the area of a triangle? Half base times height. Bless you.
Half base times height.
Okay. Bless you. Now, going to that triangle then. You've got your right triangle. I have a 6, a right angle, and a 10. What's my missing side? Well, what's the missing side length? How do I figure that out?
Not so tall.
Pythagorean theorem.
You do 10 squared minus
10 squared minus 6 squared, and you get,
like 40.
well, you get 8, you get 64, which is, wait,
Yeah, I was close.
So this is a 6, 8, 10.
yep.
Never heard of that.
This is, now guys, what we just did there was use Pythagorean theorem we just used Pythagorean theorem out loud. And that's fine. Or, write it out. You're gonna get the same thing. Now, you might have also recognized it's a 6, 8, 10 triangle, which is 3, 4, 5. Okay? A 6, 8, 10 is a 3, 4, 5 triangle, it's just double. So if you recognize it, great. If you don't, is it the end of the world that you have to use Pythagorean theorem? No, not at all. So now you know that your big B is 1/2 6 by 8. What's half of 6? Ladies, stop talking. What's 3 times 8? So your big B is 24. So fill in the blanks. We know that our volume was 56, so it's 56 is 1/3 of 24 times something. Right. So you just type in the calculator, what is 1/3 of 24? 8. Okay. So by doing problems like this, it's not making it any more difficult or anything like that. You're doing something that we did the very first day of second semester. You're using Pythagorean theorem. You're using 1- and 2-step algebra solving skills that you've been using. So it's I don't know, 5th, 6th grade, somewhere in there. All that's different here is it's exactly 5th, 6th grade. That is the international time looker at her, which gives me a vertical height of how much? Okay? That's how this works. All right? May? All right, let's do a combo.
Okay.
Combo. Now, don't. You can't. It's awful. Now, what I want you to think of, this is it's a prism with a cone cut out of it. Okay? It's a prism. Yes. It's a prism with a cone cut out of it. Have any of you guys ever used a spade drill bit?
Yep.
A spade drill bit is a drill bit that's got well, it kind of looks like, you know what a spade looks like on in a deck of cards? It's not that, but
See, I was thinking about
What was that?
That was like a crushed cheese.
it looked kind of like a very bad, it looked like a piece of garlic, actually. I don't
That was like a crushed cheese.
It did. So anyway, let's try this.
Oh, that have you done?
So a spade bit is what they're called. Looks kind of similar like that. It's not as rounded. It's more of a straight edge to it. But if you ever took a spade bit for drilling holes in wood or whatnot, if you use a spade bit, it's tapered, which means that as you drill into it, the point is narrower as it goes through it, it widens itself out. That's why most flat drill bits look like that. So if you just went into a side of a post with a spade bit, you'd get a coned out hole. All right. Now that's kind of what this is. So if I did this and spun this around, we drilled a hole. So if I wanted to figure out the volume of this, the volume of this whole thing would have been, well, what did it start with? It started with a prism, didn't it? What got cut out of it? Cone. So it's the volume of a prism, subtract the volume of a cone. When you're working with combos, with volumes, it's, what was the hole made out of? If it was put together, you just add them together. This is just, I subtracted that piece of material. I cut that material out.
It's like the shaded.
What's that?
It's like the shaded.
Yeah, very similar, very similar. So we start by just writing formulas. Well, volume of a prism is big B times how far apart they are. Volume of the cone, 1/3 big B. Oh, I'm sorry, the cone is a pi r squared times how tall it is. Now, this being a rectangular prism, you'll notice that all three side dimensions are the same. 6 by 6 by 6, which makes this a, which is called, when you have it all sides the same, remember what that's called when it's three-dimensional? A cube, very good. You're on the right track. When you have 6 squares put together, they're all the same side, it's called a cube. Hence why it's cubed. Yeah, dot, right? So the big B here is going to be 6 cubed, otherwise known as, well, it's 2/16. I'm sorry. It's 6 by 6 times 6 tall. So that gets me 2/16 when I multiply all those 6s together.
Wait, what happened to the other one?
From that, I have to subtract out, well, according to my diagram, it told me that the radius of that cone was what? 2. So I subtract out 1/3, oops, 2 squared. How tall is that cone? 6. And I throw a pi in it. Working volumes, especially when you know everything, is ridiculously simple. It is pure formulaic work. It is all formula stuff. It's a matter of just piecing it together. Now remember, your formula sheets that you guys have, every formula that you guys need to know for all of this stuff, surface area, volumes, just areas of the bases, everything is on here. You just have to know, is this a circle or is this a circle? All right, yeah! All right, and then you put stuff together, okay? Do I need to press buttons or can you press buttons? You press my buttons enough, I know that. What'd you get, Isaiah?
190.87.
190.87?
Yeah.
What's my units? My squared or my cube?
Your square.
Remember, volumes are cubed. Remember the dumb way to remember that? How many consonants are in the word volume?
3.
How many vowels are in the word volume?
300.
You want to turn the volume up more than area.
3. 1, 2.
This is the international dial for turning up volume.
You bring your 3 notches.
She's so funny.
Why are you just being eye contact with me?
Because you don't believe me.
How are you?
Turn it up.
Break up the 2s. Woo!
What did you say?
I weep for you. All right, let's make this more difficult.
It's the world's smallest island.
Yes, sir. What if I want to do surface area now instead? Same thing, but here's the thing though. Now, if I was subtracting, hey guys, hold on. Shh. If I want to do surface area, he's like, oh, you gotta do the same thing, but you're working surface area. Think of it this way. If I take this, sorry, here's just closer. I wrap this up, I'm covering everything, right? Do I have more or less to wrap? I have more to wrap up. I had to add that, but what don't I add? I add the cone, but what do I have to back out? Back out. Because you can't wrap a circle. See what I'm saying? You're on the right track there. So watch what happens. Now, if you had to find the surface area of this, if you had to find the surface area of the prism, no big deal. Formula work. The minute I cut a hole in it, I have gained surface area on the inside of the prism. Okay? I can now take, I feel bad by taking everybody's papers all the time. I can now take my wrapping paper and wrap the inside spot now. It goes inward. So I've added more surface area that needs to get wrapped up. So you have to take the surface area of the prism, add to it the surface area of the cone, because that's what we just added in. But what can't I wrap up? Circle. The circle. I can't wrap up the circle at the top. Okay? I can't wrap up that circle that's at the top. So with the formula then, you go back by writing everything out. Well, surface area of a prism, twice the area of the base, plus the perimeter of the base, how high it is, how far apart they are. Pi r squared plus pi rl minus a pi r squared. All I've done here was write out the formulas that I would have to use.
Then cross out the.
Very good. I can, just like Hannah was saying, you can cancel out your pi r squareds right away because you're counting the same thing, and we don't need to worry about it because there's a hole there. Okay? So I know that I don't have to worry about the pi r squareds. My base, in my prism, what's the base? It's a square, isn't it? So the base is a square, so it's going to be 2 times the 6 squared. Everybody okay with me writing it like that?
Yeah.
Okay. What's the perimeter if all 4 sides are 6s? 24, good. How far apart are they according to the diagram? 6. We have our radius here is 2 pi, but what do I have to use to find the slant height? Pythagorean theorem. Because according to my diagram, I know that the vertical height of that cone was 6, and I know the radius was 2. Using Pythagorean theorem.
A tree just fell in my house.
Oh my gosh, really?
Yeah.
I'm sorry.
These 2 days have sucked. She's okay, she's home, but yeah, so that's great.
So you just have to use Pythagorean theorem, guys. We just use Pythagorean theorem to go across and get that slant height. When you use that, what's 2 squared? What's 6 squared? 4 and 36 is how much? 40. According to the calculator, when you take the square root of 40, you get 2 root 10. And then it's just a matter of putting it in the calculator. Okay? That's how this stuff works. It's just real quick. I don't think I'm going to give you too many of those styles yet today. We'll probably spend more time on that tomorrow. But you get the kind of the basic idea. Last little bit to talk about are spheres. Okay. Spheres.
Earth is black. One long.
Continuing.
Yeah. But it's oval shape.
Spheres. Spheres are 3-dimensional circles. Okay. Now, one of the reasons that we have, well, in Algebra 2, we talk a lot about graphing. And we do graphs in just about every single section. And one of the things that we graph is we graph things that are in 3 dimensions. Well, in order to graph something that's in 3 dimensions, you have to have what's called the x, y, z plane. Okay? No, you don't have to draw this. I'm just showing you how this comes about. Now, what happens here in Algebra 2 when we start talking about 3-dimensional objects, that just means you have a horizontal, a vertical, and an outward distance. That's what we call our z-axis, whether it's coming forward or going backwards. So you wind up with circle going around one way. Let's see how well I can do this. Yeah, a circle going around flat. So I have a circle going through the x-y axis, a circle going between the y-z axis, and then I have a circle going between there, and a circle going through here.
No, that's like the.
That's the Big Bang Theory.
And how many circles is that? 4. If you count 4 as a lot, yes. Especially if you only have 2 fingers. 4 would be more than what you could count to, so that would be a lot more than what you have. If you only had 2.
You talking to Michaela?
Oh, really?
So that equals 4.
I knew you was talking to me.
So your sphere, the surface area of a sphere is nothing more than this. Surface area of a sphere, 4 pi r squared.
You know that's why we group things by 5?
Yeah. Because you can pick them up and take them.
It's like built in to our brain.
Wait, what?
That like how like 5 is an honorary even number.
A volume of a sphere is 4/3 pi r cubed.
Oh, because I was gonna say the surface area. Because I didn't think about the volume. I was thinking about the volume when you were writing surface area. Because I was like, oh, I didn't even put it over 3, but now I see.
So the last 2 formulas from working that we're going to work with, really in chapter 12, well, really in for all of the shape stuff, is surface area of the sphere and then the volume of the sphere. Remember, the sphere comes from 4 circles. That's how they're generated. That's how they're built. And then the volume just winds up being 4/3. So surface area, you have 4 pi r squared. Volume, 4/3 pi r cubed. As you get into this, let's see if there's the one I had. Oh, nope. If I want to find the surface area and the volume of this, if I go surface area and volume, what do you do? What's 16 then?
Oh no, it would be 8.
I did the same thing. Earlier today, I thought that the 16, I glanced at it rather quickly. I thought the 16 was a radius because sometimes they'll draw the radius off to a side. I didn't recognize that there was an arrow there. So that I know it happens, okay? So in this case here, the only thing you have to figure out is that you're given a diameter. If you have a diameter, what's your radius?
8.
8. Well, it's half, so. What happened to encouraging each other? Why not try to encourage each other?
It's definitely a dress.
Yeah. This
Yeah.
is all wrong. This is all
Yeah,
wrong.
jerkwad.
Is that a dress?
This is a romper. It's a romper.
Is that a dress? It's a dress.
Mine's a dress versus a romper.
Who cares? Anyway, 4 pi r squared. What's 8 squared? Double it. Double it.
Why you square it?
Yeah, if you put it outside the parentheses, would you get a different answer?
No, because as long as you write it as time to be alright. It's just habit of mine to write it this way. I get that. And then if we go the other way, bless you. Same deal. You just type in the calculator. Type in the calculator like that, you wind up with 4/3 in the calculator. You put in 8 cubed times pi, and I think your calculator gives you a fraction for it. If not, it gives you a decimal. I think it gives you 2047. Does that sound right? Yes, sir. Yes, sir. Anytime that there's pi in an answer, if it's not like, you can always leave it in terms of pi, but what'd you guys get for a decimal on this?
2, 1, 4, 4.
Oh, caret button's cube. I forgot to do that. What was it?
2, 1, 4, 4, 6.
That's without pi. Anybody get the answer with pi?
No, that is 5. If it's
Was it,
5,
was it 2047? 48. Okay. So it's the same thing as 2048 pi over 3. Either one of those is fine. 44 or 48?
No.
No, I meant like if you,
Like where you get the decimal, what I told you.
Oh, sorry. Yes. And then our units were meters cubed. Okay. Yeah, remember guys, either way, if you're using pi in the answer or you're giving me a decimal, either one is perfectly fine. It's just a matter of making sure you write down what you're doing. I know I ask a lot. I'm sorry. Do those, please. In the 12.6 section, I just grabbed 2 of them. Guys, let me explain this real quick.
Oh my god.
On the surface, on those it says just find surface area. I'm asking you to find surface area and volume with just those 2 examples and just go from there instead of just rewriting other problems. You just do both at the same time. It actually isn't because the other ones are really easy. It's the same thing we've been working on for the past 5 weeks.
But you've been doing
Nothing
math
really
for
has changed on any of this, and all of the formulas are all right there. And I'm giving you some time right now. It shouldn't take more than 10-15 minutes.
You've been doing math for like the last
Yes, sir.
51 years.
Yes, please do. Okay? Please do. All right?
What was yesterday's homework?
I don't remember off the top of my head, but it's on the calendar.
Don't change